So hello and welcome to this presentation about proactive and reactive support for SUSE Linux Enterprise Server. Today you have a chance to look behind the scenes how SUSE supplies proactive and reactive support. You will learn also what you can do to make best use of it. My name is Thomas Göttlicher. I'm the director of the Level 3 Support and Maintenance Department at SUSE. I'm a rather technical person, so this presentation will also look at this from a more technical perspective. Let's have a look at the agenda. I will start talking about the big picture, and then, as the session title already implied, talk about reactive support and proactive maintenance. And when we talk about support and maintenance, we also want to touch on topics like lifecycle and long-term support. As I promised, I will also share best practices, things that you can do to make best use of support and maintenance. And at the end of this presentation, there's also time for questions and answers. Let's start looking at the big picture. We are talking about SUSE Linux Enterprise Server. It's the open, reliable, compliant, and future-proof Linux server choice that ensures that enterprises' business continuity. So what does that mean? We're talking about an operating system for the enterprise, for data centers. That's where things need to work reliably. An environment where compliance is a requirement. So it's the Linux server that's for business-critical environments. And at SUSE, we believe that business-critical infrastructure just has to work. Stable and reliable and secure. So how do we do that? How do we provide an operating system that's fit for purpose in critical environments, that's secure, that's stable, and that's compliant? Subscriptions is the answer. Subscriptions are based on 3 pillars. On the left-hand side, there's hardware certifications, software certifications, and security certifications. Hardware certifications with hardware vendors. Software certifications with independent cloud service providers, for example. And security certifications. And when we talk about security, an important aspect is a secure supply chain. You want to know where does the software come from which you install in the heart of your infrastructure, and who had a chance to touch it. When we look at the right side of this diagram, there's the commitment. So for example, the life cycle or partnerships, also the collaboration with the community. As we're talking about open source, community is key. So this is about commitment, that you can rely that things will work in the future, that you can rely on us. And then there's the center, and that's the main part of this presentation today. That's about support services, so to provide you fixes for security issues, stability fixes, and that you can get quick help. For example, guaranteed response time or availability or 24/7. So this comes with, we are taking this from 2 angles. One is support. If you experience an issue and want to get quick help, then support is there for you. You can call them and they look into the issue in a reactive way. You call them, these engineers look into the problem. And the other angle is maintenance. So this is the proactive way, where SUSE proactively provide you fixes. So the fixes get to you, and probably even before you realize that there's a bug. So that's the optimal case. And this marks the 2 main chapters of today's presentation. Let's look deeper into reactive support, how you can get quick help if you run into an issue. Let me explain this diagram. So this marks the 3 different levels of support, and this is also reflected in how the organization at SUSE works, the different teams and departments, how they interact, and the different levels of support provided. If you run into an issue, you reach out to customer support, and you reach out to those guys. They help you. They help you with questions on the configuration issues, installation issues, and those engineers are not call center agents. They are trained engineers. They are into Linux, so they are experts. Then there is the second level, level 2 support. That's about actively looking into a problem in depth. And there are engineers who are experts in networking. There's experts who are experts for the kernel. And then there is this dotted line. And this marks a bit a border. It's actually not a real border because the teams interact very much with each other. But that marks the handover from the customer support organization to the engineering organization. The responsibility is code fixes. So these engineers, they look into fixes that require code changes. They also collaborate with the product development teams, the ones who wrote the code, who maintain the code. When they work together with the product development teams, they also ensure that customer requests have a priority over implementation of features of new products, because if a customer needs help, this has priority. In order to be available, we use the follow the sun model. And what I noticed is when I look how these engineers work, they are really dedicated in finding solutions. I saw them that they did not stop when they found out it's not the operating system, but the problem is in an application from a different vendor. They continued giving hints how this application needed to be configured, so the problem is solved. The number of cases up here is higher. The complexity increases here. So the level 1 and level 2 support, they solve the majority of cases. When it's getting really tricky, really complex, then level 3 support comes into play. And let's have a look at how a code change gets to you. This is about program temporary fixes, PTFs. This is a package that contains fixes. So if a issue is reported and needs a code change, it's provided as a package, as a PDF. And those PDFs, they are specific to this certain customer issue. And they are released, and those released PDFs are fully supported until the next maintenance update fixes that certain bug. We aim for minimal changes. So if you receive a PDF, it changes only things that are required to fix that certain bug. We don't want to introduce more changes because every change has a risk that something changes in a way that it surprises you in a negative way. So minimal changes, and the packages are safe and the integrity is guaranteed. They are digitally signed. We track which fixes we ship via a PDF to which customer. So think of you open a ticket for a certain package, say there's a problem, you get a fix as a PDF. If you run into another issue in the same package, you want to have all fixes included in the next PDF which you receive. So you don't want that fixes disappear out of a sudden. PDFs are supported until they are obsoleted by the next maintenance update. So the next maintenance update is supposed to include the fix that was shipped via a PDF. In case it's not included for some reason, the PDF is still supported. We also have mass PDFs. they are released for all customers, but that's more the rare case. If we want to supply fixes to all customers, we usually use maintenance updates. So PDFs are for one specific customer, maintenance updates are for all customers. There's also test packages, which are very similar. They are used during the debugging of a problem. So they are supplied to the customer for the test environment, and they are not supposed to be in production environment. They contain debug code, and we cannot guarantee that the fixes shipped in a test package also make it in the next maintenance update. So please don't use those in production, but wait for the PDF. Next slide, I want to run you through a very simplified workflow. So you know how the different teams interact in providing you a fix, resolving an issue. So we see on the left-hand side the customer, then we see custom support, that would be level 1 and level 2 support. Then we see level 3 support, and on the right-hand side we see the developers, maintainers, so the product development teams who also implement the features on those certain components, and they also help with finding fixes for the code they know best. Let's start on the left. A customer encounters an issue. They reach out to the customer support, and the customer support engineers, they start with initial analysis. They find out this requires a code change. It's something that needs to be fixed in the code. So they hand it over to the level 3 support team. What happens now is that it's being decided what's the best collaboration model is to get this fix done as quickly as possible. So in some cases, the engineers on the level 3 support team, they create the fix on their own. In other cases, they hand over the ticket to the developers. And sometimes they collaborate. And it heavily depends on which components are involved, what's the complexity. Sometimes there's multiple components. So multiple product development teams need to be involved. And this collaboration is then orchestrated by the level 3 support engineers. The aim is to find a fix. Once a bug fix is identified or created or developed, a test package is created. And this test package is provided to the customer. The customer can install it in their environment, in their lab, for example. And in case it does not fully solve the problem, the feedback is given that bug fixing still needs to happen, so another iteration is happening. In the positive case, the customer can indicate, yes, this solves my problem. Then a PDF is supplied. And this PDF can be installed in the production environment, and all is fine. In parallel, this patch, this bug fix, is also put on the queue for the next maintenance update. So this is happening once the case is closed, to make sure that the next maintenance update also contains the fixes that were provided as a PDF. There's one ask which I have. Please provide feedback on the test package. This is essential so the engineers can provide you a PDF, and we can also proceed with the maintenance update. This helps a lot. So installing the test package in the production environment would look like it solves the problem, but there is a risk that later on it breaks because a fix is not seen as it works or it doesn't work. So we don't know, should we include it in the next maintenance update? And your feedback helps with having this included in a way that we can easily proceed and you get your fixes in the next maintenance update. So until now we talked about reactive. So considering there's a problem and we need a fix because a customer identifies there's an issue in their environment. Now let's switch gears. Let's talk about proactive maintenance in a way that you get the fixes in a proactive fashion. So SUSE engineers look into what needs to be fixed, and you, in best case, get the fixes even before you notice that there's a problem. So this is about software updates with security fixes and stability fixes. Maintenance updates. They contain security fixes and stability fixes, and they are released periodically. So what does that mean? So on the one hand side, we don't want to overwhelm our customers with too many updates for the same package. So you don't want to schedule installation of updates again and again and again. So not too often. On the other hand, we don't want to make you wait for too long for fixes. So the engineers, they try to find exactly the right balance. And as a rule of thumb, I think we could say if there's one very significant fix, an update is released immediately. So we are not waiting until certain time windows or so for the most packages. If there's something urgent, it's being released. Or if a huge number of minor or medium fixes has accumulated, then also an update is released. This should help with having the right balance so you are overwhelmed with too many updates, but also not waiting for too long. And as we're talking about maintenance updates, long-term support is also a topic. I will come to that later in detail. There are certain challenges with maintenance. We want to fix bugs, but at the same time, we don't want to change the functionality. So if you install updates, there should not be negative surprises that something changes which you don't expect to change. So it's quite a challenge. Fix it, but don't touch it. Fix it, but don't change it. So that's quite a challenge. We have some principles later on that help us with conquering this challenge. Backporting fixes from upstream is not trivial. Think of packages like the kernel or OpenSSL. This needs experts to backport fixes. And most important, there must be no regressions. If you install updates, nothing bad should happen. So no new bug in a bug fix. And you use SUSE Linux Enterprise Server as a platform. You run applications from other vendors on top. And those applications, they expect certain interfaces. Application binary interfaces or application programming interfaces. And those libraries, they need to stay compatible. So no incompatible changes of those libraries. And all PTF fixes need to be included. It would mean a regression if you received a PTF to resolve an issue that you reported to the customer support, and you install the updates, and the updates would revert this fix. So PTF fixes need to be included. That's the challenges. We do have certain principles. Those principles have been in place since the early beginnings of maintenance. In 2001, triggered by the request of mainframe customers, SUSE established structured, coordinated, professional Linux maintenance. There was none before. So since 2001, these principles are in place. The first principle, minimal changes. So updates should only change what's required to change. This also means no new features. So that's the principle. I will come to exceptions later on. But in general, there should be no new features in an update. It should fix bugs, but not provide changes. This also means no version upgrades. Usually, if the major version of a package changes, it indicates that something has changed significantly. We don't want that. how do we provide fixes? We use the initial package, and on top we apply patches. So we backport from later versions the fixes and apply them to the initial package. And this means the major and minor version stay the same. So looking at the version of a package is not a good indicator which fixes are included. So if you want to find out whether certain security fixes are in the package, the version number is not a good indicator. There are certain security scanners out there who only look at the package version. So if you are about to pick a security scanner, that's something I would recommend to look for, because otherwise you would see a lot of false alarms by security scanners who look only at the version. If we have a fix for one architecture, we supply the fix for all supported architectures. And all maintenance updates are tested. That's the principles. But where's rules, there's also exceptions. So one exception, for example, is we may consider version upgrades. If it's simply not possible to backport a fix from a later version, then we may consider a version upgrade. In that case, it's carefully evaluated that this does not cause incompatibilities. Quality assurance. All updates are quality assured. They are tested. They are tested for the bug fix. This means, does the bug fix actually solve the problem? But more importantly, it's tested for regressions. Does the new update not cause any problems? Does it not include new fixes? Does it not change things in an incompatible way? Those tests are being run in an automated way and also manually. There's a really cool tool for automated tests that's called OpenQA. And it works like this. It's a tool that can take screenshots and can emulate mouse clicks and keystrokes. And it has a database of screenshots, and it compares whether what it sees via the screenshots matches what it should see. So that's a way to have a very visual way of testing whether something has changed in a way that's not compatible. There's way more different automated testing, and on top, there's also manual testing happening. The next chapter will be about the life cycle and long-term support. You may have seen this diagram in a different session already. It's a very important one. Let me explain it. The x-axis, there's the time. And you can see the different support phases over the time for SUSE Linux Enterprise 15. So there's the different service packs. What you can notice is that there's always some overlap from one support phase to another. And let me explain a bit more in detail what you can expect. So in channel support, you can expect maintenance updates, you can expect security fixes, stability fixes for all the packages that are supported. You can call the support for help. And this is this dark green phase, followed by this light green LTSS phase. This is where you get the most important security fixes. And afterwards, there's also the reactive supported phase. That's where you can call the support for help, but you cannot expect that things like updates are pushed to you. And by this way, how this is stacked, you have a lot of choice. So you can choose which service pack you want to use, whether you want to migrate to the next service pack. So there's always a bit of overlap, 6-month overlap, which gives you time to migrate to the next service pack under general support. Or you can decide that you want to stay on LTSS. So depending on your scenario, on your use cases, on the environment which you have, you can pick which puzzle pieces you want to use to create the life cycle for your use case. And if you look at for how long SUSE Linux Enterprise 15 is supported, that's quite impressive. 20 years of an operating system, that's quite some time. And LTSS gives you the commitment that SUSE knows the code and maintains the code over a really, really long time. So where to use LTSS? If you are in an environment where regulations do not allow you to migrate to a later service pack, which is under general support, examples could be certain certifications, or if you run an application from a different vendor that's only supported on one certain service pack, then LTSS could be an option for you. Or if you run a system which will be decommissioned soon, and it's not worth to invest in a migration, you may probably want to look into LTSS. In the slide before, let me go back, there's this 6-month overlap from one service pack to another. If this is not enough time for you, if you run a really complex environment and the migration takes longer, LTSS could be also an option for you. So that's what I would like to, what I explained about what SUSE does, what SUSE offers. I talked about reactive support, how it's supplied, maintenance updates, how they are created and how they are supplied. Now I want to talk about what you can do to make best use of all that. Keep your systems updated with the latest maintenance updates. If you run an outdated system, this has a higher risk of outages. And an outdated system also has the risk of a longer problem resolution time. So it's a higher risk that it breaks, and there's a risk that if it breaks, it takes longer to fix it. So installing the latest bug fixes and security fixes via the maintenance and security updates, that's highly recommended. Some people may say, never change a winning team, never touch a running system, or my system is not connected to the internet. I don't need maintenance updates. There's a prominent example. There was a bug in the kernel that froze the system after more than 208 days of uptime. This means, although the system has been working for, had been working for more than half a year without problems, and a system not connected to the internet just crashed after some time. So installing updates makes sense. There could be reasons why you cannot install updates. Certifications or third-party applications which insist on something. In those cases, if you want to report a bug, it helps a lot if you're able to reproduce that issue in your lab on a fully patched, on an updated system. So this helps a lot with a quick resolution. And one more hint. Some companies consider outsourcing the maintenance of their Linux environment to a different company. There's different companies and they have different offerings, and some install and maintain the Linux systems, install the latest updates, some don't. You only get what you pay for. So if you compare quotes from different companies for where you want to outsource, your maintenance, look what they really provide, and I'd recommend a paragraph that says that they keep the systems up to date. In the end, it's your systems, your workloads, your customers, and your business that suffers if something goes wrong. So that's what you can do proactively. Install the latest updates. In case you run into an issue, then open a case in the customer center, in the SUSE customer center, in SCC. And provide all the necessary information. So attach the log files, the core dump, support config. And in case that it's a system down, production down situation, please also explain the business impact. So how many users are affected? Is it a production system? Do you have already a workaround? What did happen shortly before the system went down? What did happen afterwards? What did you do? So all this information helps the engineers to find a solution quicker. And while debugging, they may schedule a phone call, or they may offer a remote session. A session where you can share your screen, and if you wish, also can grant access. So that's how the engineers will work with the customers, finding a fix. That's the best practices, and this brings me to the last slide, a summary. What we learned today: maintenance, updates deliver stability fixes and security fixes. So please install the updates. The support engineers, they provide you enterprise-grade support. If you open a case, please attach all the relevant information. This helps with a quick resolution. And I talked about LTSS and the life cycle. If you cannot migrate, or don't want to migrate, or have reasons not to migrate to the latest supported or general supported service pack, there's LTSS, which gives you choice. And all this is to keep your business-critical infrastructure up, running, and secure. Thank you. Thanks for your time, and enjoy the rest of the conference.